Welcome to Snow Day Proof video number 3. In this video we are going to be proving the alternate exterior angle theorem. And the alternate exterior angle theorem states that if two parallel lines are cut by a transversal, then alternate exterior angles are going to be congruent. So alternate exterior angles, if we think back to alternate interior angles, they're going to be very similar. Alternate interior angles were angles that alternated inside the parallel lines. Our alternate exteriors are going to alternate on the outside. So if we were to look at some examples of what alternate exterior angles might look like, if we were looking at this diagram to the right, we would consider angles 1 and 8 to be alternate exterior angles. They're on the outside of our parallel lines, and they're going to be alternating. There's an angle in between them on the outside. The other set of alternate exterior angles would be angles 2 and 7. So what we are going to be trying to prove in this video is that these alternate exterior angles are congruent. So again, we just have to prove one set of these. We are asked to prove angle 1 is congruent to angle 8, given that our lines are parallel. So one thing that's helpful to do in proofs is to think back to previous proofs we have done. Sometimes you might be able to see some patterns that emerge, especially if you're dealing with very similar type theorems, theorems that deal with the same type of shape, or with parallel lines. You will begin to start to see some patterns that will help writing these proofs become a little bit easier. So before I get started, what I'm just going to do is I'm just going to jot down a few different ideas that might be helpful as we go through this proof. Now they might not all be helpful, but they are things that we've talked about recently that have proven to be helpful so far with what we have done. Again, just a reminder, you'll hear us say this a lot, definitions and postulates you can use anytime for any proof. If you want to use a theorem in the proof, you have to have previously proved that. So just thinking back to some of our recent things that we have used, we have already proven the alternate interior angles theorem. That was proven in video 1 with me. We proved the vertical angle theorem in class. In video 1, we discussed the corresponding angles postulate. In video 2, Ms. Blaylock discussed the linear pair postulate, and she also proved that the consecutive angles, that should say theorem, it was a typo. Let me cross that out so we don't have any confusion. The consecutive angles is a theorem. There we go, if you can read my little chicken scratch there. We have proved the consecutive angles theorem though, so we can use that in future proofs as well. Alright, so as we said, our first step that we're going to want to start with is usually going to be based off of what we are given. So in this proof, we are given that L is parallel to M, and our reason is going to be given. Alright, so now I need to figure out how that I can get from the step that I've been given to prove that 1 and 8 are going to be congruent. So I'm going to look at what we have already done, and I'm going to look at that list that we listed earlier, and I'm going to start out by trying corresponding angles. So I'm starting with angle 1, like I said right here, so I'm starting with angle 1. Its corresponding angle would be angle 5. So I'm going to put the statement, angle 1 is congruent to angle 5. Now this may not be the right step, this may be. Sometimes you have to go back and adjust your proofs as you go, but we're going to see how far this can take us. So angle 1 is congruent to angle 5 based on the corresponding angles postulate. So we're getting closer to that angle 8. We still haven't quite matched angle 8, but one thing that should be pretty obvious right now is that angle 5 and angle 8 are going to be vertical angles. And of course we know from proving this in class a couple days ago, vertical angles are always going to be congruent. So my next step is going to be that angle 5 is congruent to angle 8. And I know that by the vertical angle theorem that we've already proven. Again, it's a theorem, but we have proven it, so it's fair game. Alright, so right now it's going to be very similar to what we were doing in the alternate interior angle theorem. I have that angle 1 is going to be congruent to angle 5. And angle 5 is congruent to angle 8. So just like in the alternate interior angle theorem, we're going to be able to use the transitive property of congruence to say that angle 1 is congruent to angle 8. Again, angle 1 congruent to angle 5, angle 5 congruent to angle 8. So since angle 1 and angle 8 are both congruent to the same angle, we can say that by the transitive property of congruence, we have proved that angle 1 is equal to angle 8, which is our alternate exterior angle theorem. So there you go. We have yet another proof in our repertoire. And go ahead and make sure you have that copied down in your notes. Now, we've already proven the alternate exterior angle theorem using one version, but I just want to illustrate a point with you guys that just because you're proving a theorem doesn't mean that you will necessarily prove the theorem in one specific way. There are also other ways to prove the alternate exterior angle theorem. I want you to make sure you have that first one down in your notes. If you want to copy this one down into your page as well, you can, but this is mainly just to show that sometimes you may be able to prove something in more than one way. So I'm still going to start with my given, that L is parallel to M, and that my reason is given. But let's say that you did not see the corresponding angles right away. Let's say maybe the first thing you noticed is that angle 1 and angle 4 are vertical angles. And let's say maybe you said that the first step was angle 1 was congruent to angle 4 because of the vertical angle theorem. Now you might realize that angle 4 is actually a corresponding angle with angle 8. So you're going to make the statement that angle 4 is congruent to angle 8 by the corresponding angles postulate. So what we have basically done is, from our first proof of this theorem to this proof, we basically switched the order of using our vertical angle and our corresponding angles. And you will see that sometimes you can do things in a different variety of steps and still arrive at the same place. Because what we can see now is that even though we're using different angles than we were using in our first proof, we still have the transitive property of congruence in place. We have angle 1 is congruent to angle 4, and angle 4 is congruent to angle 8. This time, instead of them both being congruent to angle 5, angles 1 and 8, angles 1 and 8 are both congruent to angle 4. So since angles 1 and angle 8 are still congruent to the same angle, even though if it's a different angle this time, we can still use that transitive property of congruence to say that angle 1 is congruent to angle 8. So again, I'm not super concerned if you write this one down. The main point is that you understand that there may be more than one way to prove the same theorem. But make sure that you have at least one of these down, get everything copied down, and then come back and see Ms. Blaylock in our next proof video.